In this video, we're going to look at a story problem involving variation. So let's take a look and see what we have. If the height of a rectangular solid is held constant, the volume varies jointly with the length and the width. If the volume is 250 cubic inches when the length is 10 inches and the width is 5 inches, find the volume when the length is 9 inches and the width is 6 inches. Okay, so let's get started here. Now, anytime you've got a problem that involves variation, it's usually a three-step process, especially when you're first starting variation problems. The first step is going to be to write a formula. Now, if you haven't already, you might want to watch my video on direct variation. That would be the most basic kind of variation. This one is talking about joint variation. It says varies jointly. And joint variation is like direct variation with two variables. So let me give you a little formula. If I know x varies jointly with y and z, that would mean that as x gets bigger, y and z are going to get bigger, or as the product of y and z get bigger, x is going to get bigger. But we don't know by how much, so that's where we have a constant of variation. So we would say x varies jointly, we're going to say equals, and then we have to introduce this constant value, this k value, and it varies jointly with y and z. Okay, so we have both y and z in there. If it varied directly with y, it would just be the y. So jointly just means you have two variables involved. And if you had varies inversely, you would go k over y. The y would be in the denominator. That's another topic, but you may have seen that since you're doing variation problems. So you want to memorize these little formulas for variation. Varies directly, varies jointly, and varies inversely. This is the varies jointly. And you could have a problem that has more than one of these things, but most of them are, when you're first starting out, are just going to involve one: joint variation, direct variation, or inverse variation. So we're going to focus on joint variation in this problem, and we know that it says if the height of a rectangular solid is held constant. Well, this k is your constant value, and that's really what the constant's going to be in this particular example. It says the volume varies jointly with the length and the width. So down here in my example, I have x varies jointly with y and z. In this problem, the volume is your x, and the length and your width are your y and your z. So let's take this problem right here. The volume varies jointly with the length and the width. Let's use V for volume, and L for length, and W for width, and write a formula. So we know the volume varies jointly, and we need to put our K in there, as the length and the width. Length and the width. So that's the first step, is to translate this fact into a little formula. Now again, it says the height of the rectangular solid is held constant. That's going to end up being our k value. And it helps to know something about the volume of a rectangular solid as well. Rectangular solid is a fancy word for box. So let's draw the first situation. It says if the volume is 250 cubic inches when the length is 10 and the width is 5. So let me draw something that sort of resembles that here. So the length is 10 and the width is 5. 10 inches, 5 inches, and it doesn't tell us the height. Okay, so we'll draw the height in there. I don't know what the height is, so I'm just guessing. Okay. So now, how do we find the volume of a rectangular solid? Hopefully you remember that the formula is length times width times height. So basically this this saying at the beginning, or this sentence at the beginning underlined in purple, is just the formula for volume of a rectangular solid. All we're doing here is we're looking at two rectangular solids that have the same height. That's what is meant by the height is held constant. Constant means it doesn't change. So we've got two rectangular solids with the same height. That's all it's saying. It's fancy talk. So our first situation, we have the volume is 250 cubic inches when the length is 10 and the width is 5. All right, so in all these variation problems, you're going to get a sentence that allows you to come up with a formula, which is what we have first up there. Then you're going to be given a specific example that's going to allow you to find k. So remember, our k value, our constant value, was this height. And sure enough, they told us the volume, which was 250, and they told us the length and the width. So we can plug those values in. 250 for the volume equals the length, which is 10, times the width, which is 5, times our k value, which we don't know, but we can now find because we've created an equation with one variable. So we have 250 equals 50k, and if we divide both sides by 50, we come up with k equals 5. So now we know that that height is 5. At the beginning, they said the height of a rectangular solid is held constant, but they didn't tell us what it was. Now we know that it has to be 5, which is just a coincidence that it came out the same as this length here. So this is 5 as well, the height. Now we know that in the next example, or the question, now they want us to find the volume when the length is 9 and the width is 6. So they want us to find the volume. Let's go down here and do that. Well, if you're going to find the volume, you have to know the length, the width, and the height. We know the height now. We figured it out. That's our k value. And sure enough, they told us the length is 9 and the width is 6. So all we have to do is plug in that information. V equals L, which is 9, times the width, which is 6, times the height, which we determined is 5. We multiply all that together. Let's see, 5 times 6 is 30, times 9 would be 270. So my volume would be 270 cubic inches. So this is a pattern for variation problems. Your first step is going to be to determine the formula. And this one happened to be a common volume formula, but they're not all that way. This one you probably knew. Volume equals length times width times height, and they were saying it in sort of fancy terms using the language of variation, but they're not all like that. Then, once you get your little formula, they're going to give you some specific example of that formula that's going to allow you to solve for k, which in this case was the constant value of the height. After you find that k value, they'll give you another situation where you'll have to use the k value that you found to plug in with the other information that's given to determine the last variable, the unknown variable. That's the general pattern of all these variation problems. I hope that helps, and just keep practicing. You get better and better at these as you see this 3-step process.